All right, right now you should already have your Cornell Note template created. If you don't, pause the video now so that you can create it and then get ready to take your notes. Today's date is November 18th, 2014. Our topic we're going to be discussing for Unit 6 is about expressions and equations. Today's objective is to determine if two expressions are equivalent using models, pictures, and algebraic expressions. The essential question I want you to be able to answer is how can you write algebraic expressions and use models to decide if expressions are equivalent? So modeling equivalent expressions. Equivalent expressions are expressions that have the same value. So there is a vocabulary word there. Equivalent expressions are expressions that have the same value. So the scale shown on the right is balanced. Write an expression to represent the circles on the left side of the balance. So here is our left side of our balance. And we want to write an expression that represents what we see. So we have 2 on top and 3 on bottom, and they're together. So we'll have 2 plus 3. The value of the expression on the left is 5. It equals 5. Write an expression to represent the circles on the right side of the balance. Again, we have 1, and then we have 4. So we put those together. Our expression is 1 plus 4. The value of the expression on the right is 5. Since the expressions have the same value, the expressions are equivalent. Please notice expressions do not have an equal sign. They have numbers and an operation, but no equal sign. Or it could have numbers and letters as long as it does not have an equal sign. Writing an algebraic expression. An algebraic expression, vocab word, is an expression that contains one or more variables and may also contain operation symbols such as plus or minus. A variable is a letter or symbol used to represent an unknown or unspecified number. The value of a variable may change. That's why it's called variable. It varies. A constant is a specific number whose value does not change. So if we look in our example or our table here, it says algebraic expression. We have a constant 150. That number is not going to change. It's always going to be 150. Here's our operation, plus, and here's our variable y. You also have the algebraic expression w plus n. You see that it has no numbers, but it still has a variable and an operation. So it makes it algebraic. Even if it's just the variable by itself, because it is a variable, it is an algebraic expression. Here are examples of non-algebraic expressions where you do not have a variable, you just have numbers. In algebraic expressions, multiplication and division are usually written without the symbols, and you've seen this before. Instead of having the multiplication sign, you have the number and the letter right next to each other. This means multiplication, or you have the dot. And then you have division. Instead of having the division sign, you have it written in fraction form, 3 divided by n. There are several different ways to describe expressions with words. In the table below, you have the operations, addition, subtraction, multiplication, and division, and then you have words that you will see in word problems meaning those operations. Plus, sum, more than is addition, and you can read the rest of the table. Please become familiar with these key words for these operations. So now we're going to write algebraic expressions based off of simple sentences. So you have the sum of 7 and x. Well, the sum tells us we're going to add. So the algebraic expression would be 7 plus n. The quotient of z and 3, well, quotient, if you go back to our table, quotient means division. So we're going to be dividing n divided by 3. Sometimes you'll have to write a phrase or pick the correct phrase that represents the expression. So here we have 11x. Again, we just learned that when the letter and the number are right next to each other, it means multiplication. So you would want to write the product of 11 and x. 8 minus y. The algebraic phrase is y less than 8. Modeling algebraic expressions, we're going to use bar models to represent the expression. So here we have 7 plus y. So we would have 7 individual pieces plus, so that means we're going to add on x, whatever that could possibly be. So this model here, our bar model, represents 7 plus y. Let's look at a bar model for division. Z divided by 3. So here we're going to have z, whatever z is, and we divided it into 3 parts because that's what our denominator says. And z divided by 3 is represented by one of those parts. So this bar model represents z divided into 3 parts. Algebraic expressions are equivalent if they are equal for all values of the variable. For example, x plus 2 and x plus 1 are equivalent. So let's look at our example. Katrina and Andrew started the day with the same amount of money. Katrina spent $5 on lunch, Andrew spent $3 on lunch, and $2 on an after-school snack. So step 1, you want to write an algebraic expression that represents the money that Katrina has left. So let's read it again. It says Katrina spent $5 on lunch. So whatever Katrina started off with is our variable because we don't know that. But we know that she spent 5 of it. So we're going to subtract from whatever she started off with minus 5. So here's our bar model that represents that. Whatever she started off with minus 5. Step 2, we need to write an algebraic expression for Andrew and what he has left over. So again, whatever he started off with minus the $3 that he spent for lunch, and then minus the $2 that he spent for the after-school snack. So here our bar model represents that. Here are your practice problems. If you need to go back over any of the steps or any of the notes, please stop here, rewind, and re-listen to the video. I'll go ahead and read through your practice problems, write all the questions out, and answer them. Question number 1. On a math quiz, Tina scored 3 points more than Julia. Juan scored 2 points more than Julia and earned 2 points in extra credit. Write an expression and draw a bar model to represent Tina's score and Juan's score. Did Tina and Juan make the same grade on the quiz? Explain. Question number 2. Write an algebraic expression with the constant 7 and the variable y. Question number 3. The town of Rayburn received 6 more inches of snow than the town of Greenville. Let G represent the amount of snow in Greenville. Write an algebraic expression to represent the amount of snow in Rayburn. Question number 4. What are the variables in the expression x plus 8 minus y.